chemical properties, okay, or chemical reaction. You know, there is nucleophile and electrophile, right? Alcohol has a tendency to act as
But sir, your voice is very low.
1 minute, please. Am I audible now?
Yes, sir.
Okay, so see, chemical reaction, you know what is nucleophile and electrophile, right?
Yes.
So basically, nucleophile is the one which is having more electron, the electron rich, that is nucleophile, and electrophile is electron deficient. But here, alcohol has a characteristics to act as nucleophile as well as electrophile. That depends how the cleavage or the breaking of bond you are doing. According to that, it will be acting as electrophile or nucleophile. So first we are going to discuss about this. Alcohols are very versatile compound and alcohols react both as nucleophile as nucleophile and electrophiles. Now this depends that which bond you are breaking. ROH we have. So which bond we are breaking, according to that, the scenario will take place. Okay. So I'm going to write alcohols as nucleophiles. Alcohols as nucleophiles. So basically, if the bond between OH, the bond between OH is broken. That means if you are going to break this bond, okay, OH, OH is broken, then they act as, they act as nucleophile. OH bond is broken, then act as nucleophile or react as nucleophile. I can give you an example. Let's say this is your R and this is your O and this is your H. So what will happen if you are going to react this with a carbocation nucleophile? If you are going to react this with a nucleophile. So you can see that oxygen has lone pair, so it will be attacking on this, and you will be getting RO. Hydrogen is there. Basically, what will happen? I will tell you. Hydrogen is there, and since oxygen donated electron, so it will have positive charge. Donated electron, two lone pair it has. That's why there is one more lone pair, and then this. Okay, and at the end, you know what will happen? Since oxygen has positive charge, so it is highly unstable. So in order to stabilize itself, oxygen will take electron from hydrogen, and you will be getting ROCC like this. Are you getting my point? And H2O will be eliminated. Is that clear? So basically, all I want to say is that if alcohol is there, and if you're going to break this bond, at the end you can see this bond is broken, right? So this, in this case, it will be acting as nucleophile. And when you are going to break the bond between this R or O, that means carbon and O, then it will be acting as electrophile. I will show you. There is condition for acting as electrophile. First write this. Let me know when you are done with this.
Done.
Alcohol can act as electrophile, that means electron deficient compound, only one in one case. When the alcohol is protonated, that means alcohol already reacted with H plus. That means alcohol already acted as nucleophile, we can say. So protonated alcohol as electrophiles. And it is possible when CO bond will be broken. So I'm going to write the bond between CO is broken when that means alcohol react as electrophiles. Electrophiles. And as I have written here that protonated alcohols, so we can write one more point. Protonated alcohol react in this manner. Protonated alcohols react in this manner. Only protonated alcohol. If I'm going to show you the reaction, very easy it is to understand. This is your alcohol, RCH2OH. And first you are going to protonate it. Protonate it, that means proton is going to react with alcohol. As you know that oxygen has lone pair, right? So oxygen has lone pair. So what it will do? It will attack on this and this will form RCH2OH2 positive. OH2 positive. So many times I have told you positive charge on oxygen is less stable. Actually, what happens? The elements which are more electronegative, that is stable if it is having negative charge. That is stable if it is having negative charge because it has a tendency to withdraw electron. So it will be a stable, negative charge will be stable on more negative element. If you are going to do opposite, like if you are going to put positive charge on more electronegative element, it will be unstable. Okay. Now Br negative is there, that is nucleophile. Now RCH2 and there is your OH2 positive. OH2 positive. Oxygen is basically, I told you, very unstable when having negative positive charge. So oxygen will take electrons from carbon. So carbon will have electrophilicity, deficiency of electron. At that time, this nucleophile will be attacking on carbon, not R, because oxygen is taking electron from this carbon. So what will happen? Br will be there since back attack is there. CH2 will be there. R is there and OH2 will be in the form of water. So I think it's very simple. Protonated alcohol react as an electrophile. Protonated alcohol after it becomes O will have positive charge, unstable. So it will take electron from carbon. So carbon will be now electrophile and there is a nucleophile which will attack to satisfy this carbons. Let me know when you are done. Austin, I need to talk to you. Can you unmute or send message in chat box? So I have been watching your assessment test just after class. You are not attempting that. Is there any genuine reason for that? Why you are not attempting? I attempted every rest. Actually, I got it today. Let me check. Alcohol, phenol. That's this. Alcohol, phenols, and ethers. Preparation of alcohol. It's pending. I got this Tuesday. There were two and I attempted both. Which chapter? Alcohol, phenols. Okay. Umam, are you done with this? I just need to go through the first one. Also, it was Austin. Umam.
Yeah, done.
Okay. So Austin, we just started chemical reaction. Chemical reaction instead of physical properties. We will do the physical properties at last. So chemical reaction, alcohol, as you know that electrophile, nucleophile. Alcohol has a tendency to react as both nucleophile and electrophile. As you know that this is your, let's say this is your, this is your alcohol. So alcohol act as nucleophile when you are going to break the bond between OH. So bond between OH is broken, then they act as nucleophile. First, there is an electrophile on which this alcohol is going to attack because oxygen has lone pair, so it will attack. When it will attack, oxygen will have positive charge, which is unstable. So in order to stabilize itself, oxygen will take electron from hydrogen and satisfy itself. Now you can see in the reaction, alcohol is acting as nucleophile by the broken off or cleavage of this OH bond. Is that clear, Austin? Okay. Take a screenshot. Okay. Now see, when we are going to talk at when alcohol is going to react as electrophile. Alcohol is going to react as electrophile. There is a condition only protonated alcohol. That means first you are going to react this alcohol with the proton. So you can see RCH2OH positive it becomes. Okay. And now there is a nucleophile that is waiting. As you know that O positive is unstable. So in order to stabilize itself, oxygen will take electrons from carbon and it will become neutral H2. And now there will be, since carbon is donated its electron or oxygen withdraw electron from carbon, there will be electrophilicity at carbon. So this nucleophile will be attacking from backside. Okay. So you can see here, this is how it will be acting as electrophiles. I think it's clear to both of you, right? Is that clear? Can you change the slide, Austin? Now see. See, so we have this R, there is CH2, and there is OH. So basically, on the basis of this electrophiles and nucleophiles, the alcohol's chemical properties are divided into two parts. divided into two parts. When cleavage of OH bond takes place, it is another chemical reaction for alcohol. And when cleavage of CO bond is taking place, then the chemical reaction. So the first one we have the reactions involving cleavage of OH bonds. Reaction involving cleavage of OH bond. Okay. So first we are going to study this and then we are going to study this. First of all, I would like to ask a question. Tell me whether alcohol is an acid or base. Come, alcohol is an acid or base. So basically alcohol is an acid. So we are going to study acidity of alcohols and phenols. And phenols. Umam, are you getting my point?
So I was taught that alcohol is actually both acid and basic. It's
No,
weak
no,
acid.
alcohol is an acid. I'll
Okay.
show you. Basically, it gives H plus. It is a weak base, a weak acid. Basically, in all the organic acid or base are weak. Okay, when you are going to talk about acid strength, so that is inorganic acid like HCl, H2SO4, HClO4, HBr, HI. These are strong, and all the organic acid like uh, carboxylic acid, alcohol. These are weak acid. Okay, as compared to inorganic acid. Is that clear?
Yes.
Now, as acidity of alcohol and phenols, and we are going to see. So, reaction with metals. As you know that in class 10th you have studied when acid react with metal. So, if you remember, when acid is going to react with metal, what will form? There will be formation of salt and hydrogen gas. Yes or no? Salt and hydrogen gas. So, in the same way, we are going to have this. If alcohol is here, and you are going to react this with Na. I'm going to take 2 moles only to balance it. What will happen since it is an acid, so it will go in positive and there will be negative, and this sodium will be going to this. So it becomes 2RO negative Na positive. In the solution, sodium will lose its electron, so it becomes Na positive, and this will be H plus. 2 moles of H plus will be converting into H2. See what happens. This loss of 2 electron will take place, okay, and this 2 electron will be gained by 2 hydrogen and forms H2 gas, and this we call it sodium alkoxide. Okay. In the same way, whenever an alcohol is going to react with metal, it will give you salt plus hydrogen gas. Let's take another example. C 6CH3 CCH3, and then again CH3 is there, and OH. This is your tertiary alcohol when you are going to react with ammonium. So only for balancing this is taking place, say 2 or something. So what will happen? What will be the product? Very simple it is. Since ammonium is tertiary, like the valency is 3. So it will be something like that, CH3. You can see O will be there. And then this will be multiplied how many times? 3 times and aluminum. Because you know that alcohol has one valency. Like in class ninth, you have studied formula basic. Aluminum has a valency 3, chlorine has a valency 1. So it will be multiplied AlCl. So this alcohol has valency 1 and this has a valency 3. So it will be like this. And to balance it, you are going to multiply it by 2 plus hydrogen gas will be equal. And this is called aluminum. And since this is your tertiary, so we are going to write third, that means tertiary. How many carbon is there? 4. So bu, and this is butoxide. And this is your eighth. Alk is if it is one carbon, then methoxide, if 2 carbon, ethoxide, and alkyl group, that means alkoxide. Is that clear? Hmm. Let me know when you are done with this. Are you done with this? Both of you done with this?
Yeah.
Very good. Now the alcohol stays with metal because it is acid, so give you salt plus hydrogen gas. You also know that when acid react with base, what forms? There will be formation of salt as well as water, as well as water. Now you can see, first I'm going to show you phenol or alcohol. And phenol is also an acid. Okay, this is your phenol. I'm going to take, and you are going to react this with NaOH. So the reaction is very simple. This will have negative, this will have positive. This is acid, so H plus and negative. So this will be going to this. So this becomes basically phenoxide ion. This becomes basically O negative and A positive, and it becomes phenoxide ion. Or we can write sodium phenoxide. Sodium phenoxide and water will be in the solution. Is that clear?
Yes.
Now, if you want to react, basically alcohol and phenol react in the same manner for acidity. If you are going to see, if you are going to react this with Na, that means matter. So you know what will form. Very simple it is. This is your phenol. So O negative is there, Na positive is there, and this is your sodium phenoxide, and hydrogen gas will be evolved. In order to balance it, you can multiply it by 2, and here the product will also be. So its name is again sodium phenoxide. I think it's easy, right? Let me know. Are you done with this?
Yes, I'm.
Okay. Please do respond whenever you are finished. Now, so you know that Lewis base is the one which is going to donate electron, and Lewis acid is the one which is going to take electron. Okay. So let's say this is there is a base, that means electron rich species, and this is your alcohol, like this. So basically, what happens here? This is your base, and this is your acid. So first of all, this electron will be gained by this OR minus. So what it will be? OR, and you can see this, and we can write like this. And this is having deficiency of electron, so this will be attacked by this base. Basically, this element uh, eliminate H plus. So this will be attacked by this, and it becomes BH. You know that base converted into conjugate acid. Conjugate base you have studied, and acid converted into conjugate base. base. So basically, all I want to say is that conjugate, when you have an acid, any acid you have, okay. So if you are going to remove one H plus or H plus, then you will get conjugate base. Then you will get conjugate base. You have studied this in class 11. And when you have base, and if you are going to add H plus, then you will get conjugate acid. Wait a minute, please. Can you see the screen, both of you? Am I audible?
Yes, sir.
So see, if someone is going to ask you, what is the conjugate acid of, let's say, H2O? H2O, what is the conjugate acid? So what you are going to do, add H plus to this. You know that H2O can take H plus because it has a lone pair, and you will get H3O positive. So for conjugate base, you can say this is your acid. Just wait a minute. No, no, no. We need to write conjugate base, right? Just wait a minute. I got confused. So again, if you are going to eliminate H plus from acid, you will get conjugate base. So let's say H2O. If it has been written, you need to write conjugate base. So you need to remove H plus, and this will be your conjugate base, OH negative. So right now, H2O is acting as acid. And if someone is going to tell you, write the conjugate base of this, conjugate acid of this. What is conjugate acid? You are going to add H plus to this, and you will get H3O positive. So it's not necessary that every compound will have conjugate acid, conjugate base. Water is a basically, what do we say? It is acting as both. It can act as both conjugate acid, conjugate base. So basically, what we can see, if you are going to see HCl, HCl cannot be conjugate acid because it cannot accept more electron, more H plus. But if you are going to write conjugate base for this, just subtract it, write it. So this is your conjugate base, and this is your acid. Are you getting my point? This is inorganic physical chemistry, ionic equilibrium. If you want to write conjugate base, just remove one H plus, you will get conjugate base. If you want to remove write conjugate acid, just add H plus, you will get conjugate acid. Is that clear, both of you?
Yes.
Um, Are you done with this? Both of you. Um, this is your A, this is your B, and this is your C. Tell me the acidic strength, which one is the most, right in increasing or decreasing order of acidic strength. Very good, Austin. Mom, I want answer from you. So very simple it is. This is your primary, and R is plus I effect. This is your secondary. This is from two sides, and this is your tertiary. R has plus I effect, so getting support from three. So as you know that already we have studied in acidic carboxylic acid that acidic strength or acidic character is directly proportional to electron withdrawing power and inversely proportional to plus I or inversely proportional to plus R or inversely proportional to pKa or directly proportional to Ka. So this is getting electron from one side, two sides. So getting electron, that means less acidic. So the answer will be A, B, C. Is that clear?
Yes.
Let me know when you are done with this. I think you are done after this. You are going to arrange this. Take your time, but do it correctly, Humam, especially you, because you do it a little bit slow. I want uh, you to do manage your time and accuracy as if there is any problem, you can ask me again. Propane 1-ol or 4-methyl phenol. Can you compare in that? Always remember that this phenol is more acidic than alcohol. Why it is so? Let's say this is your alcohol, right? ROH. So when H will go, it will be RO negative, right? Something like this. Okay. Now, if you have a phenol, simple phenol, anything. So OH is there. Let's say CH3 is there. CH3 is there. After eliminating H plus or giving H plus, what it will become? So O negative CH3. Now, what will happen? See, very simple it is. This is your acid. This is your conjugate base. The conjugate base, if it is more stable, it is more acidic. So this is your acid and this is your conjugate base. So I think this conjugate base is more stable due to resonance. Yes or no, Austin? And there is no resonance, so it is less stable. So basically, generally phenol are more acidic than alcohol. Is that clear? Yes, but if there is methyl acidity decrease, yes, it will decrease. But at the same time, the minimum alcohol that you are going to take, propane, 1-ol is there. So in this case, acidity decreases as well, right? Yes or no? Austin, when it will go, negative charge is there. It will be supported by 3 carbon. And here it is supporting opposite. That means inversely is only one CH3 is there. Here CH2, CH2, CH3 is there. And inductive effect has a effect up to 3 carbon. After that, it decreases. So overall, this will be more acidic. Okay. Let me know when you are done with this. First, Mom, are you done with this?
Yes, sir.
Which one is the most acidic? Mom. So very simple it is. If you are going to draw the structure, this is your, you are not audible. No, still not audible. I don't know. Two, four this, six this. The rest I don't know. 2, 4, 6. Then comes your 3-nitrophenol. So phenol you are going to write here and 3-nitrophenol. Then comes your 2, 4, 6. Then comes your 2, 5, right? Then OH is there. 3, 5. 3 and 5. NO2 is there. And then comes your phenol. That is good. Then comes your methyl phenol, 4-methyl phenol. And also, Austin, this is at fourth carbon. After third carbon, we suppose that the inductive effect decreases. So the most withdrawing power in this one, I'm going to take A, B, C, D, E, E, and then F. Most withdrawing power will be the most acidic, so B is the most acidic. After that, you can see D. This has 3 withdrawing power, this has 2 withdrawing power, then comes your D. After that, what we have? C, at least 1 withdrawing power. After this is your phenol and this is your methyl phenol. Methyl phenol at least will have some plus I effect, at least some. So it will be lesser acidic than phenol. So then it comes E, then F, and then at last A, because phenol is more acidic than alcohol. Both of you are done with this. Can I change the slide? Very good, Austin. Uma, please do respond.
Yes.
Okay. Now the next chemical reaction is about esterification that you have studied in class 10th. Esterification, how you did. Basically, when ethanoic acid is reacting with ethanol, you will get ethyl ethanoate, that is ester, okay, and water. So basically, there is a simple thing. If you are going to react carboxylic acid with alcohol, you will get, or either alcohol at the place of alcohol, you can use phenol. You will get ester, and as a byproduct, water. There are other ways to prepare ester that is called esterification. So basically, I'm going to write alcohols and phenol. Either you can take alcohol and phenol, react with carboxylic acid, react with carboxylic acids, either carboxylic acid chlorides, that means acyl halides, and acid anhydride acid anhydrides to form ester, to form esters. So this I'm going to just write the general equation. AR, that means benzene, arene, and R means alkyl group. If this is your alcohol or phenol, and if you're going to react this carboxylic acid in the presence of, and this reaction is reversible reaction, H plus, you will get directly either AR or R, COOR dash, CROCOR dash plus H2 plus H2O, that means C double bond O will come here and single bond O R dash will come. After that, if you have AR or R, alcohol or phenol, and you are going to react with acid anhydride CO2, CO whole twice, and O, acid anhydride. This reaction is also going to take place into H plus, and then you will get AR or ROCOR dash plus, since 2 mole will be here, it becomes directly into carboxylic acid. The byproduct is your carboxylic acid. And the next one is AR or R, you can take phenol or alcohol. If you are going to react this with RCOCl, that means basically your acid chloride or acyl halide in the presence of pyridine, and this is irreversible. So you will be getting R or AR, OCO, R dash plus HCO. So OCO means this is your carbonyl group. This is your carbonyl group. This is your carbonyl group. What is carbonyl group? CO. This is your carbonyl. That means with R dash, you are getting single bond O like this, and with R you are getting this. That means with alcohol you are getting RC double O, and with this you are getting single bond. Please do write it. Then I'm going to give you a question. With this, you can remember this. If you are going to use acid anhydride with this number of carbon, you will get a carboxylic acid. R dash C double H. Let me know when you are done. Are you done with this, both of you? Yes or no?
Yes, Adam.
No, I'm going to give you this reaction. You can do it by yourself. This is your benzene, which is connected to carboxylic acid and alcohol. And you are going to react this with this one, acid anhydride in the presence of H plus. This is called salicylic acid. I'm going to give you one more question. Here. You can do this easily. Let's see if you're able to do this or not. Just wait. I'm just trying for last one till that we need to do this question. Please do this. Only the Are you done with all this? Mom, are you there?
Yes, sir.
Have you got all of this, Mom?
No, sir. 18th and 23 I didn't.
Which one of the following on oxidation gives a ketone? I told you. If you are going to reduce ketone, you will get secondary alcohol. So if you are going to oxidize secondary alcohol, you will get ketone. 18. What is formed when primary alcohol undergoes catalytic dehydrogenation? Dehydrogenation, that means removal of hydrogen. That means a reduction, right? And oxidation of alcohol, primary alcohol. Removal of hydrogen is called oxidation, right? So when you are going to oxidize primary alcohol, you will get RD. Propene can be converted into 1-propanol by oxidation. Indicate which of the following. I told you propene and 1-propanol you are getting. CH3, CH double bond CH2. When you are going to react with basically H plus and OH minus comes into play, and negative part goes to that carbon which has greater number of hydrogen. So basically positive will go to this and you will be getting CH2 and CH2H. Anti-Marconico followed by hydroboration oxidation. C. Lucas reagent HCl and anhydrous ZnCl2. This I gave you the name in haloalkane and haloarine as well. Okay, is that clear? Kumam. Okay, see this. When you are going to react this with CH3CO means acid anhydride. So you know that I just gave you acid anhydride react with alcohol to form ester, and this is your R. So what will be the product? The R will be as it is. It is not going to react with carboxylic acid. So carboxylic acid will be as it is, and this is your R. So this will be your R. I already wrote, and then there will be double bond. That means OCO, and then CH3, CH3. Okay, OCO and CH3, and then with this carbon there will be carboxylic acid CH3 C double O. And this has a name which is, we call it acetyl salicylic acid, acetyl salicylic acid, and it is used in a medicine that is aspirin. Write it. Then we will move to the next. Let me know when you are done with this.
Done.
Now, The chemical reaction due to cleavage of OH bond is completed. Now we have reactions involving cleavage of carbon oxygen, that means CO bond in alcohols, CO bond in alcohols. So the first reaction we already did in the previous chapter. I'm going to write the name as well. A reaction with hydrogen halides. Reaction with hydrogen halides. Okay. So basically, see what happens when you are going to react alcohol with hydrogen halides. Like this is the scenario: ROH plus HX. And what you will get, this bond will be, I told you in previous chapter, that is halogens, halogens positive. This is negative, this is positive. So you are going to remove this water and Rx will be combined. So you will get Rx plus H2. And for this, we are going to use a reagent that is concentrated HCl in the presence of ZnCl2. In the presence of ZnCl2. And this is called Lucas reagent. Lucas reagent. And there is formation of carbocation in this carbocation. So rearrange if possible. Formation of carbocation is this. So rearrange if possible. There are other points that we need to write. The reactivity will be 3 degree, 2 degree, 1 degree will be it. Okay. Moreover, alcohols are soluble in Lucas reagent. In Lucas reagent. What is Lucas reagent? Again, I'm going to write concentrated HCl and ZnCl. But there, but or why they're alkyl halides, but their alkyl halides are immiscible, are immiscible, and produce turbidity, cloudy solution type turbidity in solution. In case of tertiary, if the turbidity appears immediately because carbocation, tertiary carbocation is more stable and carbocation forms very fast and Cl goes and then alkyl halide will be immiscible. So turbidity appears, cloudy solution appears very fast. In secondary, it will take 2 to 3 minutes, few minutes. And in primary, since primary carbocation is not that much stable, so it will take time to uh, form carbocation, primary carbocation. So it will take half an hour or something like that to appear cloudy. There is no, almost no turbidity. So this is how we are going to test for degree of alcohol. If you are going to react with this and you are getting turbidity immediately, that means this is tertiary. If it is showing the turbidity after a few minutes, then it is uh, your secondary. Or if it is not showing turbidity, then it is primary alcohol. Now let me know when you are done with this. Are you done with this? No. The next reaction we already done. That is reactions with phosphorus trihalide in the first chapter, haloalkane haloalkane, while the preparation of alkyl halide. If you have seen this, you remember ROH is going to react with trihalide PX3. I'm going to write, or PCl3. It's okay. PCl3. What you got is RX, and here you will get H3PO3. I gave you a trick to remember. You are going to take 3 moles of this. So ROH, you can write ROH, you can write ROH, you can write. And here I'm going to write PCl. PCl3 is there, right? Cl and Cl. I should write like this. So, just wait a minute. I should write P, Cl, 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 and remove this. So, what it will give you? PH3, H3PO3, and 3 moles of RX. Let me know when you're done with this. Are you done with this? Okay. The next is very important, and that is your dehydration. From the name, you can see dehydration is removal of water molecule. From the name, you can see removal of water molecule. That means alcohols undergo dehydration. That means removal of a molecule of water, removal of water molecule, removal of water molecule to form alkenes. To form alkenes. We prepared alcohol from alkene. Now we are going to remove water from alcohol to make it alkene. On treating with, or on treatment with, a protic acid. Protic acid, that means the one which gives H plus. As for example, you can take concentrated H2SO4, which is also known as dehydrating reagent. Dehydrating reagent. Or we can take H3PO3, or we can take H3PO4. catalyst such as anhydrous zinc chloride, or aluminum. Let me know when you're done with this. Let me know when you're done with this. Yeah, I'm going to show you the reaction. Let's say hydrogen is there, OH is there. And if you are going to react this with H plus in the presence of heat, what will happen? This H2 will be eliminated and you will get something like this. And if you are free on Sunday or Saturday evening, please tell me I need to take an extra class. If we are going to take an extra class this week, are you done with this? Both of you done with this?
Yes, sir.
Mm. Okay, so this is it for today. Are you free on which day? I need to ask you. Like on Sunday, are you free? Umam,
What?
Sunday, are you free? IST, let's say 3 p.m. or 2 p.m. IST.
So it's not possible. I have school, so I'll come back at
So at
4.
what time on Sunday? Uh, Saturday? Saturday at what time you are free?
Saturday 2 p.m. I can attend.
Saturday? No, no. At night, Saturday.
I
Saturday, like 8 p.m. or 7